In lesson 9.3, we are going to talk about multivariable linear systems, which means we're going to move past just having x and y, and we're going to get a third variable. We're going to use z. Now, you can do more variables than this. You could do 4 or 5 or 6 variables, but if you have that many, you don't want to use these methods because that would be a disaster. If you have more than 3 variables, we really want to use matrices, which we'll talk about in chapter 10. But we can do this for 3 variables. It'll work. The first thing we want to look at is back substitution. So I've got these 3 equations, and I know what z is. I know that z equals 3. So I can plug that back in and find the other variables. Now, I can't plug in here because if I plug in 3 for z, I still don't know x and y. So that's not a good idea. But I can plug in right here. Okay, so I can do y plus 3 times 3 equals 6. And so it ends up with y equals -3. And now that I know y and z, I can plug back into this one, 2x minus -3 plus 5 times 3. So that's going to give me 2x equals 4, so x equals 2. So that's using back substitution. When we write our solution, we want to write it as an ordered triple in alphabetical order. So 2, -3, 3. Now, the problems aren't always that nicely situated for us. Most of the time, we're going to have something like this. So we can use this method. It's called Gaussian elimination. And on your notes, I have the steps written out. I needed all the workspace I could get, so I cut that out of my version. But what you're going to do is you're going to take 2 of the equations and use elimination to get rid of one of the variables. So I think I'm going to take these 2 equations. We'll just start with the first 2. And it's already set up really nicely to eliminate the y. So let me rewrite these. X plus y plus z equals 6. 2x minus y plus z equals 3. Okay, so we're going to add these. We get 3x, the y's eliminate, plus 2z equals 9. Put a star next to that. We're going to come back and get that equation in a little bit. All right, so that was equations 1 and 2. Now I need to take a different 2 equations. I can take 1 and 3 or 2 and 3, it doesn't matter. And I'm going to do the same thing, eliminate the same variable. So I'm going to pick equations 2 and 3. And the reason I chose those is because they also already have a negative y and a positive y. So this is all set up nice and neat. And so when I do this, I get 5x, the y's eliminate, the z's eliminate, equals 5. Oh, that was great news. X equals 1. Okay, and now just like my last problem, I want to plug back in to get my other variables. I don't want to go back to the original because all I know is x. But if I come back to the start equation, I can plug in 1 here and figure out z. Looks like z is going to be 3. And now I can go back to one of the originals. I'm going to go back to original 1. So 1 plus y plus 3 equals 6. And then I have my solution here. 1, 2, 3. All right. I will show you the next problem in the next video.